express the line segment from the point P to the point Q as a vector valued function. So we have a point P, we have a point Q, we want the line segment from P to Q. So it has an orientation, it goes in a certain direction from P to Q. So there's the line segment. So there's a sketch of the line segment. The point P is -1, -1, 2. And the point Q is 2, 3, -1. So R of t is equal to x of t, y of t, z of t. This is a vector valued function of the variable t. T is the input, and the output is essentially three functions, x, y, and z, that then form a vector in space. And x, y, and z are going to be the components of the line segment. So we can figure that out from thinking of the, let's say, the vector form of a line. So recall the vector form of a line would be x, y, z. In our case, it'll be x of t, y of t, z of t equals. And then we have a point. So we'll take the point P, expressed as a vector, plus t times the vector from P to Q. The vector from P to Q, where t will go between 0 and 1. So that's our domain, because the domain is the set of input values that create the curve, in our case, this line segment. So t will go from 0 to 1. So this is going to be the vector -1, -1, 2, plus t times the vector from P to Q. So we have to take the components of Q minus the corresponding component of P. So 2 minus -1. I'll write it down here so we can see what the calculation is. 3 minus -1 and -1 minus 2. So that's the vector from P to Q. So this is -1, -1, 2 plus t times 3, 4, -3. So this is the direction vector for the line. And t is the parameter. And this is a point on the line in vector form. The vector form of the point, because we have to add a vector plus a vector. So we see then that our R of t is x of t, which is -1 plus 3t, or 3t minus 1. The y is -1 plus 4t. This is a t here, not to be confused with the plus sign. So we're distributing the t and then combining by adding the vectors. So -1 plus 4t, and finally 2 minus 3t. So here we're expressing the segment as a vector valued function. We call it R of t for the radial vector of any point on the segment. The segment is, here's the origin, there's the segment, there's P, there's Q, and we're thinking of the points as being vectors emanating from the origin, and we're thinking about the terminal point of the vector. That would be the position vector of a point on the curve, in this case, the line segment. So this point here near the midpoint would be from a value of t roughly 1/2. So this would be like R of 1/2 specifically. But in general, R of t would give us a point on the line segment, or the curve in general.